What if an AI model 100 times smaller than GPT-4 just outperformed the world's best, and it's completely free and open source? This isn't science fiction. It's happening right now. A radically new AI architecture is emerging, and it could redefine what we think is possible for machine intelligence. Could this be the biggest leap toward true AGI? And is HRM about to replace everything we know about traditional AI models? This new AI breakthrough from HRM is truly a game changer. The design is so radically different from traditional LLMs, large language models, that it feels like we're entering a whole new chapter in AI development. In this video, we'll break down why HRM is so exciting and how it might just be the future of artificial general intelligence. If you're excited about the future of AI, make sure to like this video, subscribe to NextCore AI, and hit the bell icon so you never miss the next big update in tech. The core concept. HRM is built on a brain-inspired architecture that drastically changes how it approaches reasoning. Unlike typical AI models, which use a simple chain-of-thought method to break down problems, HRM doesn't rely on hope that each step in a sequence will be correct. Instead, it mimics how the human brain processes problems by utilizing two separate modules. The high-level planner. This module strategizes, maps out the big picture, and determines the steps required to solve the problem. The low-level worker. This is the executioner. It performs the tasks and rapidly acts on the plan formulated by the planner. This process repeats, where each part talks to the other, refining the strategy based on the results, allowing HRM to adapt as it works through the task. Think of it like a chess grandmaster, the planner, who lays out a strategy, and a quick assistant, the worker, who executes the moves. This dual system thinking mimics how humans juggle strategy and action. By separating the architecture into planner and executor, HRM avoids the pitfalls of single-path reasoning, allowing for real-time correction, layered memory, and adaptive learning. It's the difference between guessing the answer and thinking your way through it. And that subtle shift changes everything. Breaking traditional limits. Here's the kicker. HRM achieves extraordinary results with only 27 million parameters. For context, GPT-1, which is considered one of the first large language models, had 117 million parameters. HRM's parameter count is a fraction of the size of its competitors, yet it outperforms models with billions of parameters on reasoning tasks. That performance doesn't just beat expectations, it redefines what's possible in AI scalability. Smaller, smarter models are becoming the new frontier. It proves that parameter count alone isn't the metric that matters. It's how you reason, adapt, and learn. HRM shows that we might not need billion-dollar clusters to reach human-level reasoning. For example, on the AGI benchmark, an intelligence test for AI, HRM scored 40.3%, while Claude 3.7 and OpenAI's O3 mini-model scored only 21.2% and 34.5%, respectively. That's not a small difference, considering HRM's size. Flexibility in reasoning. Unlike traditional models like GPT and Claude, HRM can adapt the amount of thinking it needs to do based on the complexity of the task. Most current AI models process the same number of steps for every task, regardless of how hard it is. For example, when given a simple question or a complex problem, a GPT model still works in the same rigid sequence of steps. HRM, however, can choose to loop through its reasoning process as many times as necessary. It has the flexibility to think longer or shorten its reasoning time, just like humans. This kind of flexibility gives HRM a crucial edge. If it realizes midway through a task that it made an error or missed a better approach, it can revise its process in real time, something no current LLM can do. Imagine an AI that can rethink, regroup, and replan, all during the task. HRM loops back to reevaluate, not just continue forward blindly. This recursive control lets it escape the rigid pipeline logic that most models are trapped in. It's like having a digital strategist embedded inside your machine, adjusting tactics like a human mind would. Real-world applications. What's even more mind-blowing is that HRM isn't just performing well on theoretical benchmarks. It's being tested in real-world scenarios like healthcare for diagnosing rare diseases and seasonal climate forecasting, where it reportedly hit accuracy rates of 97%. These kinds of applications are proof that HRM's innovative design isn't just for solving Sudoku puzzles. It can tackle real-world, complex problems that require deep reasoning. And it's not just tech demos. Medical professionals are already exploring how HRM can assist in diagnosing edge case symptoms, while climate scientists are using it to refine long-term weather prediction models. It's the first glimpse of an AI brain that can think beyond simple language prediction. Additionally, HRM's design allows it to be incredibly resource efficient. HRM can run on a single GPU and still outperform some of the largest AI models out there. This efficiency opens up the possibility of deploying AI agents on everyday devices like laptops, robots, and even in your car, without needing massive data centers. The reinforcement learning edge. Another remarkable feature of HRM is that it uses reinforcement learning to decide how many iterations it needs to complete a task. For simpler tasks, it may loop only a few times. For more complex problems, it will keep iterating until it finds the optimal solution. This adaptability allows HRM to handle tasks with varying complexity without wasting resources on unnecessary computations. The path to AGI. HRM's team, including former engineers from DeepMind, Anthropic, and xAI, believes that HRM could eventually pave the way to artificial general intelligence, AGI, machines that think and reason more like humans, beyond simple chain-of-thought tasks. The potential here isn't just faster AI, it's self-directed intelligence. With a strategic feedback loop, HRM models begin to approach goal-oriented behavior, solving tasks not because they're prompted to, but because they understand the why behind each step. That might be the closest we've come to artificial intuition. The key here is that HRM doesn't rely on basic prompting as a shortcut. It uses real-time reasoning and planning, and can adapt its strategy mid-process, something truly aligned with human-like thinking. Open source and transparency. One of the most impressive aspects of HRM is that it's open source. The team is making it available on GitHub, encouraging the community to test, modify, and improve it. This level of transparency in a cutting-edge AI model is rare, especially when you consider how many big players in AI keep their research closed off. A step toward the future. HRM's architecture isn't the only breakthrough being explored. Other startups are also rethinking AI models. Sakana is exploring continuous thought machines, and Google is testing out diffusion-based reasoning models. But what sets HRM apart is that it's not just an experiment. It's already working, already beating larger models with far less data and less computational power. If HRM's development continues on this path, we may soon see a shift in AI from massive, resource-hungry models to smaller, more flexible agents capable of actual reasoning. HRM is leading the way in rethinking AI architecture. It's not just about making models bigger. It's about making them smarter, faster, and more resource efficient. Its two-part system, combining a strategic planner with a rapid executor, could be the next major leap toward artificial general intelligence. So what do you think? Is HRM the future of AGI, or just another milestone in a bigger race? Drop your thoughts in the comments. And if this breakdown helped you see the next wave of AI more clearly, help us grow by liking the video and subscribing to NextCore AI. We're not just reporting AI, we're decoding the future one breakthrough at a time.